Furthermore, they acquired ThreadGrid in 2014, which nowadays is like what that is today is the cloud or on-premises intelligent malware detection. You find that basically within the Cisco's advanced malware protection capabilities. It's simple to deploy AMP in your network in various, let's say, regions, and then AMP provides sandboxing capabilities, and we're speaking a couple also anomaly detection capabilities or unknown malware through querying the threat grid in the cloud or on premises, depending where we want to deploy it. And this feature is available on Cisco on its web security appliance, which is the X-Iron port, on the email security appliance, which is the X-Iron port, on the next generation firewall, which is ASA with firepower still today, and also on the endpoints. We're going to speak when we get in a bit later on, like why does Cisco have that capability in different, let's say, places in different security products, and what is the reason for that? And it's not because of sales; it is for a good reason in there. And as I was saying, AMP on endpoints on Cisco uses two engines, Spero and Ethos, which is nothing else but the two engines used by Immunet, which is a company acquired by SourceFire, and finally by Cisco. Later on, they acquired OpenDNS in 2015, which is a cloud-based DNS intelligence to provide security for any device, anywhere, at any time, as Cisco speaks about it. What that means is that clearly, because we have a lot of attacks based on DNS, like we get redirected to, you want to access a specific resource out on the internet, and through DNS attacks you get redirected to different, you get redirected to a different URL, or of course there are well-known, let's say, bots on the internet, well-known command and conquer, let's say, centers, which are clearly DNS resolvable, and it's clearly way faster nowadays because doing all of that DPI inspection on the box. Still it drops down performance, so it's way better if we would be able to drop to know that the traffic is malicious just based on the domain name it's gonna access, or based on the IP address which got resolved to DNS. So like if I were to go today to, let's say, www.whatever.com, then OpenDNS would be able to say that, hey, that's a well-known botnet, or it's a well-known command and conquer center, or it's a well-known location infected with malware. So it is going to drop the session instantly. So you're no longer required to allow the session through the firewall and then do DPI and and consume users as resources and drop the session at that point. So it is clearly way better this way. And then they acquired Lancope in 2015, which completed let's say, the Cisco's. It gives Cisco a, let's say, a complete solution. Lancope provides strong defense against APT, advanced persistent threats, which since we're here, for those of you who are, let's say, new in the field, this being a basics class, like whatever you learn in general, try to also look at the name of that, let's say, the name of the feature, or the name of the the acronym, because it is going to tell you exactly what it does. Like let's say, what is the advanced persistent threat? So the APT is exactly what it states. Like, for example, let's look at the diagram for a couple of seconds. Okay, so let's say that this user here, the PCA, I'm going to use the other diagram, just this one. So let's say PCA, goes out on the internet to whatever destination and gets infected, and with clearly some unknown malware, which is 100% possible, even though you might have a lot of security, let's say, features and solutions deployed in your network. It's an unknown malware. It's very easy to get infected on an endpoint from the internet. So this guy PCA gets infected with malware in here. You may state, okay, but I have sandboxing built in. I have a couple of solutions of sandboxing. As you know, pretty much all new malware, the attackers are aware that you have sandboxing solutions in the network, and it's a lot of techniques that they use to avoid sandboxing detection. So a lot of smart malware is going to be able to bypass those solutions and still be delivered at the endpoint and infect the endpoint. So this guy gets compromised, malware. So how is this called APT? Very easy. They call it APT because back in the days, the malware, because we didn't had a lot of, let's say, security solutions. As soon as malware would hit an endpoint, it would start doing its job, like, start compromising other hosts, or start stealing data, start speaking with the command and conquer center, so start to signal to its master out on the internet. But nowadays, because the attackers know that we have a lot of solutions built in, once malware has been deployed on the endpoint, it can keep silent. It can stay silent for a long time. It can stay silent for a week, for 2 weeks, for a month, even more than that. And it can send like very slow beacons out to the command and conquer center. Like, you can send a beacon like each, I don't know, 24 hours, for example, or each 1 week, why not, or even longer. Just to say, basically it's gonna say, it's like a hello packet, like a keep alive, saying, dear master, I'm still here. So basically with this is very difficult to detect, because it's just like one packet or two packets, very here and there, being sent out on the internet. But that opens a channel for the attacker to actually be connected to the endpoint through this connection, and take full control of the endpoint, discover the network, and do a lot of damage in the network. So it gives the attacker, being silent, it gives the attacker enough time to be able to launch the final attack appropriately, at an appropriate time, and make sure that the attack is going to be successful and he gets whatever he wants to get from that network. It can be in different various reasons. So that's why they call it an advanced persistent threat, because it's a new threat which is very advanced and it's persistent, because it stays on the endpoint, it's silent, and it's also very difficult to detect, to keep it simple. A question from Dennis: can you explain sandboxing in more detail? We're gonna get there as well, Dennis, in a couple. So with the acquisition of LandCorp, they are able to better provide security against APTs and against new malware, against any kind of malware which is silent and which signals to the master out on the internet to say, hey, I'm here. If you know some more damage, come in. I'm connected, basically. They do that to keep things short. They do that by having full visibility in the network, which what that means is that they rely on NetFlow. So you have to pretty much everything which happens in the network, you have to capture that via NetFlow and export NetFlow to LandCorp. And it does clearly, it understands, it learns the network, how it works, and then it's going to be able to let's say create a baseline for the network. It also is going to tell you, you may ask in here, what is the baseline is wrong? Why what if when LandCorp is deployed, I'm that one also infected? What happens? Of course, it has a lot of built-in rules in order to detect if also, as it learns the network, if the network is healthy or not. But clearly, it's a long discussion to keep it short, is able to, as long as it has full visibility in the network on all traffic and it's properly deployed, it's going to be able to detect even small keep alives from being done on a weekly basis from the infected endpoint, or of course it's going to be able to detect small keep alives or from the infected endpoint towards another endpoint. So as long as you provide full visibility of the network traffic towards LandCorp, you're going to be able to better understand what happens in the network and better be alerted in case something happens, which clearly should not happen, or if you're under attack at that point. So we have spoke about a lot of terms back and forth. One of the most important one being Talos. So what is Talos is nothing else but big data analytics for threat defense, because as I was saying, you can imagine that there is no way we have that intelligence, that behavioral analysis and modeling capabilities of the network and of the malware without a huge database which is inspected with a specific scope to be able to statically define malware samples and also dynamically learn about new malware samples and be able to secure all of the clients that connect to Talos through that mechanism. And of course, Talos is the security intelligence and research group. It's a huge not a company, of course it's part of Cisco, but it's a huge department leading threat researchers supported by sophisticated systems to create threat engines for Cisco products that detects, analyzes, and protects against both known and emerging threats. And if I'm not mistaken, I think the worldwide internet group is being actually uses Talos to defend their networks against from the internet, against attacks from the internet. It is the, let's say, entity that controls and maintains the official rule sets of snort.org, Clam Antivirus, Senderbase.org, which was the cloud intelligence of Ironport, and SpanCop. And at the same time, it gathers data that is being interconnected with ThreatGrid, with AMP, and with OpenDNS. So it's basically like the big guy in Cisco, which has everything under control, has a huge team of intelligent and experienced engineers, which they do nothing else on a daily basis but write code, understand what happens on the internet, provide the security to their customers, and also chase, let's say, attacks and attackers on the internet, like what was the case with a lot of ransomware nowadays within the last years, which clearly the Talos was the, let's say, the head that made and was leading. They led the capture of those hackers that was stealing a lot of money from people by encrypting their hardware, their hard drives on their devices. And that attack was functional both on Windows devices and on Mac devices. So it's a huge database with a huge brain, both people and also database, intelligence database, which gathered a lot of information back and forth. Like, for example, just to give you a quick glimpse on that, let me find a proper URL. Here we go. It is a PDF file, publicly available. Okay, so if you look in here at, there we go, this slide. So Cisco Talos, they state that they spend more than $100 million on development and creating that group and that huge database, that intelligence. It is 1,600 plus engineers, technicians, and researchers, which is the biggest group that any vendor has out there. It's incomparable with, like, I'm not going to specify names of the competition, but with the, let's say, competition of Cisco, this is huge as opposed to the competition. 24/7, 365, 14 languages, because clearly malware can be written in different languages. So they have engineers that they speak whatever 40 plus languages to be able to understand malware being deployed across the globe. What else? 1.6 million global sensors. So what that means is that pretty much all Cisco's, let's say, platforms, the web security appliance, the email security appliances, the old Cisco's deployed IPS, the AMP on the endpoints, the cloud web security. So everything which is a Cisco product sends some data to Talos, to different various options. Even Cisco AnyConnect nowadays, the new versions, in version 4, everything sends a lot of data to Talos. And of course, they are able to better understand what happens throughout the internet and better provide security to the customers. And of course, you can choose how much data to send to Talos, but clearly, regardless of what you do, they are clearly stating that you're not going to send out there, let's say, sensitive data. They look at more than 35% of the worldwide email traffic, which is a huge amount of traffic being inspected, and they see more than 13 billion web requests on a daily basis, which is clearly a huge amount of data to be processed and to be put in the proper format, and the requirement to be able to gather, let's say, only the proper input from that huge amount of data. You get updates about 3 to 5 minutes. Each 3 to 5 minutes, the connected devices that Cisco has connected to Talos, which is going to be web security appliance, email security appliance, the ASA firewall, the AnyConnect, cloud web security, all of them get updated like within 3 or 5 minutes with new signatures and new hashes for sandboxing for fast malware detection. And look at the amount of signatures produced. It is huge, and 8 million plus rules per day within Talos to be able to dynamically detect malware, unknown malware nowadays. So it is really huge. There's a question from Neil: is the cognitive threat analytics and APT functions performed in the cloud to Talos, or are those features done on premises devices? So ThreatGrid is available as an option both on premises and on cloud, which means both. So to keep it simple, AMP basically, it's available both on premises and on cloud. Clearly, being on premises is much more difficult to upgrade, because you have to upgrade, let's say, the code behind the scenes. The signatures are updating dynamically from the cloud. But still, if there are any major changes on the code level, you have to do that on yourself. So it's not doesn't happen on the fly like it happens on the cloud. But clearly, it is Cisco has that option to provide that on premises as well for companies where security policies, the internet security policies don't let them to upload to cloud anything, like for example files for sandboxing for malware protection, for example. So if the customer requires that, then you're going to buy a huge box with those capabilities on premises. Okay. Now let's speak about Cisco's next generation firewall. So it was known initially as Firepower, which those were the capabilities from SourceFire's next generation firewall added on the SA, and they added those capabilities in 2 flavors, as a software or hardware module on the ASA firewall. Or of course, you could buy the standalone physical appliance, the SourceFire, but then you wouldn't have the specific native ASA firewall features. You'd gain only the specific SourceFire features. Nowadays, because as I was speaking before, clearly that was a good requirement at that point in order to be able to quickly adopt the SourceFire capabilities, which the SourceFire lacked a lot of capabilities on the routing side, switching side, VPN side, NAT side, but they had good next generation firewall capabilities. Cisco had to combine those two together, and the quickest, easy method for that was to be able to just put the SourceFire capabilities on the SA firewall as a software or hardware module. But as I was speaking before, that adds a lot of complexity, both from the management point of view, because you need to manage like 2 boxes. You need to manage both the SA firewall, we know the rules in there, and you also have to manage the Firepower module in there. So two different management which clearly it's not something that it's ideal. And also it was a bottleneck from the performance point of view, because the as I was saying, the traffic had to enter the ASA. Like for example, if you go to the diagram in here, because the traffic was redirected, and it still is of course now today, to the Firepower module via Cisco's MPF functionality. So like if you would look at the traffic from PCA in here, which goes, let's say, to the internet, traffic enters the SA in here physically, then through MPF gets redirected on the backplane, through MPF gets redirected to the backplane to Firepower services. Firepower does its stuff, is inspect the traffic, does the packet inspection, and then if the traffic is allowed, then it sends the packet back to the SA on the backplane, and then the SA has to do a lot of other functions, route, NAT, VPN, whatever, and then traffic exits the SA and is being routed out on the internet. And of course, the reply is gonna follow up on the same approach. So the response from the internet goes in on the firewall, is being redirected through via MPF to Firepower services. Then if allowed, then it is being redirected back to the SA. The SA does the additional inspections in there, still for firewall, and then traffic is being sent to the user. So that created a huge bottleneck, secondly. So for that reason, they came up with the Fireside Threat Defense, how they call it now. Firepower Threat Defense, or some people call it Fireside Threat Defense, unfortunately, but it is actually Firepower Threat Defense, which is a unified code for the ASA firewall and for the Firepower. So now you have a single code that supports both worlds in there. It is already available. As far as I'm aware, it's not supported, actually, for sure. We're going to speak in a couple. It's not supported by all ASA platforms, but of course it's not let's say, the appropriate time to move in that direction, because you're going to lose at this point a lot of ASA capabilities. So it's not a one-to-one match, like if you would run ASA with Firepower services against Firepower Threat Defense. It's not a perfect one-to-one match. It's still in the works, but it's probably by the end of the year we're going to have a functional, fully functional code which supports all features back and forward within one platform. Okay, let's see if there are any questions before we take a short break. From John. My question earlier was, are there notable differences between an appliance 9000 series, for example, and the SA with Firepower services? So John, we're going to have I think is the next slide we're going to get there. So I'm going to answer at that point. Doesn't make sense to answer now. Mark says you mentioned traffic redirection through not NPF but MPF. So the when the SA Cisco supported the IPS hardware software module, the ASA CX, as I was saying before, for web inspection, for DPI, it was the ARON port, nothing else but the ARON port web module, and now we support the Firepower services, likewise on the SA. And all of those advanced capabilities, Firepower. So all of these advanced capabilities, in order for the ASA firewall to inspect those, as you're going to see when we get to the implementation side, traffic would came inbound on the SA, and if it was matched by MPF, where MPF stands for modular policy framework. So modular policy framework, that is MPF. So if the traffic that is received by the ASA from IP8 to IPB FTP traffic, because you could match on the traffic based on layer 3 headers, based on the layer 4 headers, if the traffic matches the MPF policy, then you would redirect that traffic for advanced inspections to the IPS module, or to the ASA CX module, or to the Firepower module. So that was done through the MPF functionality of the SA. And then that module is going to take an action on the traffic, either allow it or not, based on the configured policies. And if the traffic is dropped, then it's going to send back to the SA a traffic denied statement. I'm going to show you when we get there at the configuration side. Otherwise, if the traffic was allowed, then it would send the traffic back to the SA, to the backplane, and then the SA would route it out to its destination, assuming that was the internet. So not NPF, but MPF, Modular Policy Framework. Neil, does the Firewall perform SSL decryption, or do you have to rely on the other SSL offload devices? So that is one thing that I know on top of my head. In 5x versions of Firepower, you had to rely on a different box. We're going to look at the release notes to confirm that. You had to rely on a different decryption box, the source file decryption box, but in code 6 you have that capability built in on the device. So in Firepower 6.0. Basil, isn't it the same bottleneck delay will be caused by the unified code as it will perform both ASA and source file jobs? Not exactly, because yes, the ASA performs so first of all, clearly the ASA performs the same functionalities back and forward. Correct. Second, I'm sure with the new code they have optimized things around to do it in a proper way. I haven't yet touched base with the new code, but I'm pretty sure because performance is very important. I'm 100% sure that they fixed something, so that the order of operation and how they do things back and forth, and also the hardware clearly was optimized to do things faster, and also to do to the processing in an optimum way. But still, to answer your question in there, the exact question, it is not the same thing. Because with the unified code, the traffic, yes, is being applied the same inspections, but it goes through the SA one time. With the current versions, it goes to the SA, then to the backplane over the Firepower module, then it's being sent back to the backplane to the SA, and then routed out. So it's like it's looped back and forward from the SA to itself, which clearly creates a bottleneck for performance-wise. So, like for example, with the unified code, traffic would reach the SA. Traffic would reach the SA from the user, get inspected, all features which we activate our policies get inspected, and then if the traffic is allowed, then traffic is being routed out to the internet or to the destination. It's one, so it passes through the SA one time only. While with the current version, with the ASA, with Firepower services, you should see this diagram in here. Like, this is my ASA firewall, which has both the firewall capabilities and also the regular ASA firewall capabilities and the next generation firewall capabilities. So this is my firewall, one big box. With the current implementation, traffic reaches the ASA firewall. So traffic is being sent to the firewall. It reaches the SA file, step number 1. The SA file does its job, to do some input. Let's say whatever the input inspections are being done, to probably create a state in the firewall entry or whatever, or you process the traffic against the input ACL or authenticate user or whatever, and then the traffic is allowed. Then traffic is being redirected to the backplane, to the Firepower module, to the backplane via MPF. Firepower then does its inspections, and if traffic is allowed, then traffic goes back to the backplane to the SA, and then exits the SA. So clearly it's not the same thing. As I was saying, first of all, with the unified code, traffic flows to the SA one time only. It's not being bounced back and forth to the backplane between the physical device, the SA, and the additional software, the additional capabilities of SourceFire. So it's one time only. Secondly, as I was saying, they have new hardware boxes we're going to speak about, which means are clearly optimized for the new code to do things better. And I'm sure that also behind the scenes in the code they have optimized things back and forward. Yasser says, hello, are we getting a recorded version of this session? I missed like an hour. Of course it being recorded, as any other INE online class is being recorded. You're going to be able to see that pretty much in 1 or 2 weeks in there. Okay, so let's take a short break. Then we get back, we speak a bit more about capabilities, features, licenses, and maybe also go to the installation side today. Otherwise, as I was saying, this class is only basics, so we speak about the requirements of the features of an integration firewall, and we're gonna do a basic installation of both the Firewall services and the Fireside Manager, see how those are being done, and do some basic rules back and forth configuration-wise for the Firewall services. And that's going to be it for this class. Everything else, like a deep dive into all of the features which are let's say supported by Firepower, are going to be done in the second class, which is going to be pretty much in the next weeks. It is being shown in the schedule.